recording. Okay, so page 33, radicals. So let's take a look. We've already mentioned square roots. Some of these you have already seen because of what we did with rational exponents. So we talk about this symbol here, which we know is a radical. So here's one little kind of a picky piece, but I think it's also important to recognize. If I said 4 squared, we know that that is 16, right? If I take -4 and square that, that is -4 times -4, also 16, okay? So when I say, what are the square roots of 16? I'm saying what times itself equals 16. You could say the square roots of 16 are 4 and -4. Okay. The tricky part is right here. When we use the square root symbol, we're only looking at the positive. Okay. So if I was just to ask you verbally, what are the square roots of 16? There are 2, 4 and -4. If I use the symbol, it's only the positive. Okay. What else did we get to yesterday when we looked at, or the day before last class, when we talked about square roots of non-perfect squares are irrational numbers. Okay. So irrational numbers, that Q with a bar on top. And what are irrational numbers again? How do we define, we're walking down the street. How do you pick out an irrational number? Okay. Okay, exactly. And so what might it look like? So irrational numbers cannot be expressed as fractions. That is very, very true. And what do they look like? Then Leo.
A number with a non-terminating or non-repeating decimal.
Exactly, both actually. So they are non-terminating non-repeating decimals, such as pi, such as the square root of 17. Okay, those are all irrational numbers. The cube root, so we talked about that as well when we looked at rational exponents. Okay, all cube roots, there's going to be 1 cube root. There's no possibility for 2. Okay, and we're saying what times itself 3 times is that number. So the cube root of 1000 is 10. Okay, and why? Because we know that 10 cubed is 1000, because 10 times 10 times 10 equals 1000. Okay. Can we take the square root of a negative? Okay, I'm seeing some shaking heads and some nodding heads. Can you take a square root of a negative? Can I say, what is the square root of -16? No. Meaning what times itself equals -16? Can you do it? No. Not unless you use imaginary numbers, right? So square root of a negative number right now, we're going to say does not exist, DNE. Okay. Whereas if I asked you, what is the square root of -8? What times itself, or sorry, cube root, not square root, cube root of -8, what times itself 3 times equals -8? It is -2. Yeah. So the cube root of -8 is -2. So we can find the cube root of a negative. We cannot find the square root of a negative. Okay. So The cube root of 49, let's look at that. Can you take the cube root of 49? We look at 49, we're like, oh, that's a perfect square. 7 times 7 is 49, but is 49 a perfect cube? No, it's not. So then that means it is irrational. Okay, so the cube root of 49, irrational. Okay. So let's take a look at these. Then square root of 49 is simply 7, absolutely. The cube root of negative 64. What times itself 3 times is 64, or is negative 64, I should say. Yeah, negative 4, right? Good. The 4th root of 10,000. It looks crazy. It's not. It is simply 10. Yeah. Okay. The 5th root of 1 over 32. Well, let's break this down. We could actually do them separately. What's the 5th root of 1? Simply 1, because 1 to the 5th, 1 times 1 times 1 times 1 times 1, 1. Okay, what's the 5th root of 32? What times itself 5 times is 32? 2. So the 5th root of 1 over 32 is 1/2. Okay, Wyatt, do you have your pencil? Take some notes, write these down. Okay, the 4th root of negative 16. Can we do it? No, but if you have negative, that's a good idea because the 4th root of 16 is 2. But what's negative 2 times negative 2? Positive times negative 2. Negative times negative, back to positive. Right? With 4 negatives, it's going to be, so this does not exist. Okay, and look at this. They were sneaky. They said, evaluate where possible. This one is not possible, does not exist. Okay, oh, look at this fancy one. 2 times the cube root of 125. So this is almost like 2 times. So 2 times, what is the cube root of 125? 5. So 2 times 5 is simply 10. Okay, moving on. Okay, this is learning how to use your calculator. So take out your graphing calculator if you've got it. If you don't have it, oh, hey, here's a place would be appropriate for your phone. If you have an iPhone, there is an app, free app called Calculate 84. Okay, I won't let you use it on a test, but that actually, when you download Calculate 84, it actually looks exactly like the graphing calculator, like the TI-84.
What's the app called again?
Calculate 84.
Oh.
Okay, but you don't need it, Zachary, because you got your calculator, but it's not bad to have just in case you forget your calculator or your calculator is out of batteries, right? So I would agree, this is fine to have your phone out for this. Do you have to sign up?
We don't have that. We don't have to spend $100.
No, you don't have to spend money on it. Yeah, yeah, like does it not look at Zachary's calculator, it looks identical. Isn't that great? Okay, so I'm going to bring up my calculator. If I want the 4th root of 10,000, ready? And this. Okay, whoops, let me clear all of this mess out. Okay, here, where are we going? Everybody with me? We're going to go to the math button on the calculator. If you scroll down on the fourth option, you'll see cube root. So I can put in, if I select that, that would give me the cube root of, let's do something that we know. Oh, we just did -64. Cube root of -64. And this calculator, like many of your scientific calculators, gets picky about the difference between a negative and a minus. Okay, so we are using the negative. So cube root of 64, and our answer is -4. Okay. If you were to ask it to do, I go back to math and I can go down to the, whoops, the cube root of, enter, the cube root of, no, not 8. I want to do the cube root of 49. You will see it gives me a decimal. That one, if it had more decimal places, you could then see that it is non-terminating, non-repeating. Okay, if we were to do the square root of -16, you can see it's going to tell you it's an error. Okay, and you can even see it's non-real. Okay. So let's take a look. Let's go back to math. Okay, what if I want the fourth root? If I go down to the fifth option there, you can see there's an X for the little index. Okay, and so hit enter. And so right here, I can put in the fourth root. And what do I want? The fourth root of 10,000. Enter, and there it is. Okay, everybody's got that on their calculators? Then, okay, so part of it, I will tell you, is learning how to use the calculator. Okay, so if you don't have it just yet, yep, you can use your phone right now. Eventually, you guys will need to buy the calculator because there are a lot of places that don't actually let you bring in your phone, right? Like for your test and your final exam, we're not going to let you have your phone. You're going to need the calculator. Okay, so let's take a look. Would you guys try B for me, the seventh root of -2,187? Okay, let's try B, C, and D for me, please. Okay. And for all of these, you can enter them in exactly as is. For your calculators, because I know most of the TI-84s give you the fill in the blank for the little number outside, the boots. Do all of you have that fill in the blank? Anybody get an X or? Yeah.
I just need to touch the screen.
Oh, you got this one. Okay.
I'm trying to figure out how to get rid of all the calculations.
Put in the zeros, I want, but I know you got a keyboard button. I don't know what to do. So 4 is my max. So the fourth root of 10. Four is going to be the X.
It's crazy. It's so annoying.
Okay. Okay, so what did we get for the seventh root of -2,187? -3. Okay, this is going to be, did you guys get this in? And you can enter it in just like this. If you wanted to, you could put in -3 times if you wanted to. You don't have to put the times button if you don't want to. You can actually type it into your calculator just as is. So I would put in It is -3, right? So -3, and then we are looking at math, and I want the 4th root. So I'm going to go down to the, whoops, nope, that didn't work. The 5th option here, that didn't work either. Let's do that. Oh, apparently it doesn't like that. So let's do this. So I want that, and then there we go. So -3. There we go.
Yeah, that's like.
Did you do this or times? Yep. Okay, there we go. -45.
Yeah.
You guys get that? Okay. This should be -45. Okay. And if you're not getting that, try putting in the times here. So -3 times the 4th root, or you could do the 4th root of 50,625 times -3. Okay. For the cube root of a fraction, then, so we can again go to math. I want the cube root. So I think most of you guys usually arrow down. The other option is that you can actually, because it's the 4th option, I can just press 4 and it automatically does that. So the cube root of 216 divided by, what was the denominator? 125. Okay. And there it is, 1.2.
Oh, so this calculator.
What?
We did it wrong. Oh, wait, okay, so. Use the frac. Yeah, okay, so I put in the 216 and then frac 125.
No. You want to divide by 125.
Okay.
Okay, so I'll tell you what that button does since you found it. Okay, so Leo used the button. So he's got mode, no, not mode, math, and then 2 frac. That first one, option 2 frac, changes a decimal into a fraction. It's not the same as you're thinking of your scientific calculator, the ABC button. That's not it. This one changes any fraction into, or sorry, any decimal into a fraction. So now it's going to take my answer, which is 1.2, change it into a fraction. It's 6/5. Okay. Or 1.2. Okay. Okay, so here we go. Some terminology then. So all of these are examples of radicals, is what we call it. Okay, the little number outside, remember we left the boots outside, the boots, the bottom, that is what we call the index. Okay, the index is our boots. Okay, and then we have our radical symbol, and the radicand is the number that is inside. So whatever is inside your house, or if we're talking about the base, when we are looking at your exponent of a rational number, that is your radicand. Yes, Kate. It definitely does. We just need to figure out how to do it. Okay, so would you guys take a moment, well, I hope Kate do, and do class example number 4, identify the index and the radicand, please. Okay, well. So so you need the, oh, yeah, no. What happens if
No, I know, but
it's
the way that
negative three?
No, they don't live with us. They're in the.
What did you do? That's so weird.
Okay, let's try.
You just write a B with a line on top.
Yeah, you go like this.
What the? Who does it?
How you do that? I never knew.
Yeah.
Okay, and then-
I put this.
Yeah. So that's the, I mean, part of the.
Yeah.
No, the other.
And then if you have a.
I don't even know, you probably don't even know how to draw plots.
You should. Yeah.
I don't know.
Okay, like, it's for sure, like technically speaking, so for those of you who don't yet have a graphic calculator, here's the deal. They will tell you, like, if you look on the Alberta Ed course, and what it says for this course 10C, it will say you don't need a graphing calculator. I will tell you that you are at a huge disadvantage if you don't have a graphing calculator, is one. Secondly, I think you guys are headed into, if you're staying at STS, you are going into 20-1 or 20 IB, in which case you need a graphing calculator. So if you have it this year, then you start learning how to use the buttons. Okay, so basically, here's the deal. If your plan is to be here next year to take 20-1, or you plan on taking 20-1, get a graphing calculator. Okay, it'll save you so much hassle and headache this year, and it will also help you out next year because you know where all the buttons are. Okay, yes, I know it's an investment. If there are questions about it, come and talk to me. We can look at some other possible options as well. Okay, because I know it's an investment. Okay, for the first one, 4A, our index is 5 and our Radican. Okay, for B, index. Nice. So the unwritten square root, the unwritten 2, the radicand is nice. And then, oh, C, tricky. The index 3. Good. That 5 is just outside. Okay. And the radicand is, yep, everything under the house there. Okay. So let's take a look at this. So this says recall. We actually haven't done this just yet, so we're doing it right now. Square root of 9 is 3, right? Times, what's the square root of 4? 2. So 3 times 2, obviously 6. If I was to follow kind of order of operations, square root of 9 times 4, what's the square root of 9 times 4? 36, and the square root of 36, 6. So what do you recognize is that they're equal, the same thing. Okay. What happens when I do addition? Square root of 9 is 3, plus the square root of 4 is 2. 3 plus 2, obviously 5. If I add these together, the square root of 9 plus 4 is the square root of 13. Is the root of 13 the same as 5? No. So they are not equal. Okay. So when I multiplied the radicals together, equal. When I added, not equal. What about division? Square root of 9 is, of course, 3 divided by 2 is 1.5. Agreed? Okay. Whereas if I divide, square root of 9 divided by 4 is 2.25. Okay. And if I take the square root of that, yeah, 1.5. So multiplication and division equal. Anybody want to guess subtraction? They've already told us not equal. How come? Square root of 9, 3 minus 2 is 1. Square root of 9 minus 4 is the same as square root of 5, not the same. Okay, so key thing is what our little math cop is saying is regardless if we're multiplying the product or the quotient of the roots of two numbers, it's equal to the root of, and this sounds so confusing. Ultimately, I like this. Let's go with this. Okay, so multiplying together or separated is the same. Division together, separated is the same. Okay, so true or false? Root 3 times root 6 is root 18. Is that true? Can I just multiply them together? Yep, because separated or together is the same thing. So it is absolutely true. Root 20 divided by root 10 is root 2. Well, because it's division, can I put them together? Yep, 20 over 10. Is that 2? Sure is. So that is also true. Addition, can I have them separated? Addition? Which ones can you separate them? We can separate if for what operations? If you're multiplying or if you're dividing, not for addition. So that is false. Okay. So here it is. The root of 8 times the root of 3 is root of 8 times the root of 3. Come on, guys. Square root 24. It's not 24. It's the square root of 24. Square root of 7 times 3 would be the same as square root of 21. Square root of 50 over the square root of 10. Same as root 5. Nice. Okay. Oh, that's kind of tricky. So let's work on one of the what's the square root of 100? Root of 100 is simply 10. So can I say then that this is the same as root 10 divided by root 2? Yeah. Okay. Okay, square root of 77. If I want it as a product, root 77 is the same as the square root of what times the square root of what? Yeah, root 7 times root 11. Perfect. Root 27 is the same as root what times root what?
Root 9 times.
Love it. Root 40. We've got a bunch of different possibilities. What could you do for that, Bryce? Root 20 times root 2. Or what else could we do? What's another option then, Leo? Root 4 times root 10. Okay. What's another option, Dominic? Awesome. Nice. So all of those are good. And when we get to tomorrow's lesson, I will tell you this is going to be our best one. These are all good. This is the best one, root 4 times root 10. Okay, so numbers, here we go. 1. All of 1. I'm crazy. 2. 3. Using your calculator is A, C, and E. Okay. 6. And A is quick, true and false. And 9 and 10.
Where's 10? There's no 10. Oh.
After 9. Okay.